Welcome to the Associated Research line leakage testing demonstration. The purpose of this demonstration is to show how you can automate line leakage testing per the medical device standard for running earth leakage, patient leakage, enclosure leakage, patient auxiliary leakage, and mains on applied part testing. Today I've provided a simple example showing how this can be done. What I'll be using today is the Autoware II software, which we use to communicate with the instruments, as well as an Omnia 8207 unit, which is a 7-in-1, does AC high pot, DC high pot, insulation resistance, ground bond, ground continuity, functional run, line leakage testing, and also has a built-in 500 VA power source, which we will use to power up the medical device for this demonstration today. Also along with this, I have two multiplexing SC6540 scanners. Here I have a 16-channel master, and here I have an 8-channel slave. Before we get into setting this up through the software and showing you what the parameters are for each step, I'm just going to briefly show the connections that I have here for this particular demonstration. So there's a lot of wires going on back here, and hopefully you can see this without too much difficulty. Basically what we have here is a medical device with 4 patient leads. And I have the 4 patient leads connected here. You can say I have 3 patient leads connected here and the 4th here. Those are going back to the master channels 1 through 4. Patient lead 1, 2, 3, and 4. I also have a protective earthing connection from the medical device, which is going here into channel 8 on this master scanner, as well as channel 3 on this slave scanner. And I'll explain in a moment why I'm using 2 scanners and why I have 2 PE points. But I basically just wanted to show how the patient leads are connected so that we can run this in an automated sequence. Additionally, what I have is I am using a linear 1 kVA power source to simulate my T2 or my transformer 2 for my mains on applied part testing. So what I have here is 132 volts going through these lines, and you'll have to forgive me, I don't have professional fixturing here, but what I have is line and neutral from the source going through a series of resistors up to the various scanner channels. Now you'll notice I have 2 sets of wires coming out from the source. I've paralleled them, and I'll show you why. This also explains why we have an extra PE connection. I have line and neutral going to these 2 scanner channels, which are 6 and 7 on the master scanner, and then PE goes to channel 8. And then I additionally also have line and neutral going to this second scanner, as well as PE going to channels 1, 2, and 3. The reason is because if you look at the standard and the way these tests are run, you actually reverse polarity at some point from T2. So here we can see T2, and we have line, neutral, going through a resistor, through the measuring device, and back up to the patient lead. Well, at the same time as running line through this resistor, I need to tie neutral in to my protective or reference point. So by putting them through 2 separate scanners, I have the capability of tying these points together without including it in the measuring circuit. So that's why I've used 2 scanners in this instance, essentially to provide isolation. So what I'm going to do here is put the camera in the mount and run through a sequence of tests for this demo. So what you're seeing here is actually the Autoware II program. And this is how I set up the tests. A little easier than doing it manually. So I've already created a line leakage sequence, as you can see here, with multiple steps. Now, I'm going to double click on this to show you the various parameters that we're looking at. Now, this is showing me all the parameters I have set up for this test. Now keep in mind this is a demo, so I've kept the limits here pretty much the same across the board for all these tests. I have a 6,000 microamp high limit, 0 microamp low limit. I've set my voltage high limit to 135 because, as you can see, for this particular medical device I'm running 110% mains, which is 132 volts. And I set the internal power source on the device to 132 so that it can run the product at that voltage. I set my voltage low limit to 129 just to make sure that my source is working properly. If it happens to dip below that, I'll get an error message. I've set my delay and my dwell time both to 1 second, we'll keep it short, and I have my probe configuration set ground to line, which means this is an earth leakage test. I have the 60601 measuring device, and I'm measuring RMS, and I'm measuring a composite signal, AC plus DC, although you do have the capability to use filtering to measure AC or DC only on this particular device. We also here have our fault conditions, our neutral, our ground, and our reverse fault condition, and our continuous run, which basically will keep the product powered up, of course given that you don't have an open neutral condition, in between steps. Given that this is an earth leakage test, we currently don't have any of the scanner channels set. So that's actually what I've done for these first 8 steps, because if we consider all 3 fault conditions for earth leakage, that takes us out to 8 steps. So on the 9th step is where I actually start doing my patient measurements. Now, I didn't do 8 steps individually for each patient measurement, but when you see how I'm doing this, you'll get the idea behind what I'm doing. You can certainly extrapolate and do as many tests as you want on as many patient leads. Now recall, on my master scanner, which is what I have set here, my SC6540 address 1, I had patient lead 1 connected to channel 1. So I'm setting, with red here, patient lead 1 high. Green is low. So I'm setting patient lead 1 high, and I'm also setting channel 15 high. And if you recall, I set my probe high to channel 15 and my probe low to channel 16. Those probes are simply coming from the Omnia, and they're just probing points that the Omnia uses to reach out and go across various points so that the MD can get a solid measurement. So once again, I set probe high to channel 15 and probe low to channel 16. Since I'm just doing a patient leakage test here, I'm only selecting my probe high to line configuration because I'm measuring patient leakage back to the line or neutral reference of the system, depending upon the polarity switching while you're running these tests. As you can see, I'm still running 132 volts, and I still have continuous on. And basically all I have here is I have my probe high, which is again connected to channel 15, going out to short to patient lead 1. So I basically simply repeated this process for patient lead 2. As you can see here, now I have patient lead 2 high connected to probe high, which is on my channel 15. For the next step, I have patient lead 3 high connected to probe high, and then finally, of course, I have patient lead 4 high to connect to my probe high. So that pretty much takes care of showing what the patient leakage is all about. And we have a few more steps here. 13, 14, and 15 outline patient auxiliary testing. So now what we have are very similar parameters as you saw in the previous steps. However, you'll notice I've changed my probe configuration from probe high to line to probe high to probe low. So now I'm using 2 probing points, much like you'd use with a multimeter if you were just taking 2 probes and going across 2 points with the 60601 measuring device. And I have patient lead 1 high set to probe high and patient lead 2 low set to probe low. So essentially we're just measuring from patient lead 1 to patient lead 2 while the product is running at 132 volts. And I repeat this process for the remaining steps. Now I'm going from patient lead 1 to patient lead 3, still keeping probe high and probe low in the circuit. For step 15, I simply am taking patient lead 1 to patient lead 4, probe high to probe low. Now for steps 16 and 17, this is where I illustrate the mains on applied part test. Recall that I brought line neutral and protective earthing to both scanners so that I can complete the circuit at the same time providing isolation. So I'm still on a probe high to probe low configuration, only this time I've got channel 6, which is line voltage. This channel here is line voltage coming from the isolation transformer T2 connected to probe high through that resistor. And then I've connected probe low, channel 16, to patient lead 1, which is on channel 1. So that takes care of the measurement circuit for probe high to probe low through the MD on the mains on applied part. However, I still need to complete the other side of the circuit. So on the slave, I've tied channel 2, which is neutral, to the protective earthing point, or our reference point, shorted together to complete the circuit on that side, but at the same time, now it's not involved with our measurement. And I've simply now repeated this process for the next step, but now I've reversed the polarity of the lines coming from transformer 2. So now I have channel 7 high, which is the neutral of the circuit, in contact with probe high, and channel 16, which is probe low, in contact with patient lead 1. And then we'll see on my other scanner, now I'm bringing line voltage from transformer 2 in contact with the PE point and tying those together as it would be exactly on the diagram for figure 17 for a mains on applied part test. And you can well imagine, you can extrapolate this out to as many steps or patient leads as you see fit, given that you have enough scanner channels to run this test. So I'm going to go ahead and save this information and jump over to my control panel. Now here you can see that the Omnia and the program are working together to load all the files onto the unit. Once it's complete, I'll be ready to test. So I'm going to go ahead and push the test button and we'll watch it run through this sequence. So what we can see here is the Omnia running through the test. We can see the voltage, we can see the leakage current measurement, we can even see the fault conditions here. Currently we're on step 4. Here's step 5, so we're still on earth leakage, and we can still see we have a G to L probe configuration here. Step 7, step 8, and now step 9, we're going to start going through various patient leads. So here we can see probe high to patient lead 1, probe high to patient lead 2, and remember probe high is channel 15, so that's just connected to patient lead 2 here. Probe high to patient lead 3, as this LED goes on, still connected to my probe high. Probe high to patient lead 4. Then we go into our patient auxiliary tests after this one. So now we can see patient lead 1 to patient lead 2, probe high to probe low. So we have our probe high, probe low here. Now we have patient lead 1 to patient lead 3. And finally patient lead 1 to patient lead 4. Finally, we have our mains on applied part test. And here we can see, getting a little more leakage, only about 1 microamp in this case. But now we have probe high to probe low, line voltage connected to probe high, which is channel 6, and probe low connected to patient lead 1. At the same time, on the other scanner, I've shorted my neutral to my protective earthing point because I've tied those points in there. And then finally, on our last mains on applied part test, I flipped the polarity of this circuit. Now we have neutral connected to probe high, probe low connected to patient lead 1, while line voltage and PE are shorted together on the medical device. You can actually see it powered up here, doing its thing. And the test sequence has completed. Now, of course, were this an actual run of tests that I was going through, we'd have many, many more steps. We'd have 8 steps for each one of these conditions. But I wanted to illustrate here how with multiple patient leads, you can actually run through and do all of these types of tests without the need for switching out the configuration. Obviously, the main time investment here is working up your fixturing to connect up to the product. So hopefully this illustrates how you can do this in an automated fashion.